Hello dear students, so welcome to GATE Wallah Bachcha Logo. So in this one short series we will be completing signals and type of signals, and we will be also doing the operation on signals also. Okay, so this will be a very beautiful lecture, and we will be completing this very important and basic portion of this subject. Okay, and it is very important for GATE point of view also. I am Siddharth Sabharwal. And we will be covering signals, basic definition, elementary analog signals, elementary discrete signals, and type of signals. Okay, so hello GW soldiers. Now you are no more a student, now you are a soldier, because now you have to live life like a soldier. You have to work hard, you have to make a timetable, you have to follow that timetable with wholehearted hard work, wholehearted dedication, and with perfect 100% dedication towards your one goal, that is GATE 2023. Okay, so this is a brief introduction about myself. Okay, that is GATE 2021 AIR 1, Engineering Services 2015 AIR 3, MTech from IIT Delhi in VLSI. Okay, so let's start the class with a very beautiful quote, that is, push yourself because no one else is going to do it for you. You are the one who have to push, who have to work hard, who have to work hard dedicatedly for your goals. Okay, then only you can achieve very good successful life. Okay, this is the syllabus. There is continuous time signals, discrete time signals, LTI systems. Okay, and we'll be completing the whole syllabus in this one short series. Okay, this is the syllabus for electrical engineering, so we'll be covering for electrical as well as for electronics both. Okay, electrical as well as for electronics both. Next, so let's start chapter 1. Chapter 1, that is introduction to signals. What is a signal? What is a signal? Signal has two dependent variables. Now dependent variables, here we have to observe signal is same as the functions in math. Okay, the function in math. For example, in mathematics we have already studied, we always study that function of x. So here x is a dependent variable. So in signals we have two dependent variables, that is t and n. So where we use t and where we use n, this is dependent on the type of signal. Where we use t as a continuous variable or n as a dependent variable. Okay, so we have continuous time signals. The continuous time signals are those where the function or the signal is valid at all values of the dependent variable, that is at all values of t. So the function is dependent on all values of t. Okay, on all values of t it is dependent. Okay, so we can see that here, we can see that at all values of the time axis the function has non-zero and valid value. The function has valid value for all values of small t. Okay, for all values of small t. So t is a dependent variable. So remember that the continuous time signals have dependent variable small t, and the continuous time signals have it has a valid value at all values of time t. Okay, so these are the two major points for the continuous time signals. Okay, first is the dependent variable is t, ठीक है ना, and the function has dependent variable. The function has dependent variable. The function has dependent variable small t, and the function has values f of t at all values of t. At all values of t. Okay, so these are the two only points, important point for the continuous time signal that you have to remember. Now let's come on to discrete time signals. So discrete time signals are those which have dependent variable, that is n. So it is written as f of n, that is signal has dependent variable n. Signal has dependent variable n, and a very important point here is that the function or the signal fn has a valid value at integer values of n only. At integer values of n only. So remember this, remember this always. Okay, so we can see that, for example, this is a function, this is a function. Now here the dependent variable is n, and we can see that the function has values only at integer values of n, that is 1 0 1 2 3 4 6 7 and 8. For example, let us take an example here. For example, f of n is given to us. Let us say f of n is equals to 2 times of n minus 1, and this is a discrete signal. Let us say this is a discrete signal. Now it is written that find out the value of the function, the value of the signal at n equal to 2. So it is very easy to find out. Simply put n equal to 2 here, we can get the answer, that is 2 into 2 minus 1, that is 2. But if you have to find out the value of the signal at n equal to 1.5, then since it is mandatory that the function is valid only at n values integer, thus at n equal to 1.5, the function is either invalid or 0. Okay, either it is invalid or 0. Remember it. Remember this. Okay. Now let's move on. आगे चलते हैं. Sampler. Now sampler is that it is a box. It is a box that converts continuous time signal to a discrete time signal. Okay. So it is a box that convert continuous time signal to a discrete time signal. So how does it do it? How this sampler works? So it is a very simple thing. Let us see. So it is a box that converts It is a box that converts the continuous time signal to a discrete time signal. Let's see how it works. Okay, so sampler is simply a switch. We can see that sampler is simply a switch, yeah, or sampler simply works as a switch. Okay, now in any question when we are trying to solve a numerical based on sampler, then in sampler we always have sampling instant, that is TS. Now what is the meaning of this sampling instant? So this is sampling instant. That is TS. Now what is sampling instant? Sampling instant means that the output is connected to input. Just listen to me carefully. The output is connected to input at integer multiples of TS. Okay. Here we can see that output is connected to the input at integer multiples of TS. At integer multiples of TS. Now the same thing is represented here also in this figure. Okay. So we can see that this green signal is applied as the input. This green signal is applied as the input. This is the input, and we can see that it is continuous time input because the input is available, or input is valid at all time values, all t values, right? But we can see that the output here is available. The output here is available only at 0. The output is available at 0, at TS, at 2TS, 3TS, 4TS, 5TS, 6TS. So we can see that output is equal to, I am writing an equation and it is very, very important. It is very, very important. Output is equal to input. Output is equal to input at what time instance? Output is equal to input at t is equal to nts. Okay, at t is equal to nts. At t is equal to nts. So what is the concept? How to solve the question? Now let me repeat this whole concept again. Let me repeat this whole concept again. The first point here is, in the sampler, the output is equal to input at t is equal to nts. Output is equal to input at t is equal to nts. That is, the output is connected to input only at integer multiples of ts. Only at integer multiples of ts. Okay. So now what is the concept? What is the concept? To find out the output of the sampler, what we do? What we have to do? We always have to use this equation. We always have to use this equation. So how to use it? For example, in this case, the input is cos 300 pi t. The input is cos 300 pi t. In the question, TS is given to us. TS is given to us. Now we have to find out the output. So it's very simple. It is very easy. That is, output is equal to input at t equal to nts. That is, we simply replace. We replace t by nts. We replace t by nts in the input. Okay, so what is the result that we'll get? We'll get output is equal to, we simply replace small t, the variable t, by nts. Okay, 300 pi into nts. So what is ts? Ts is 0.01 given to us, so we can put it here. So we can get that the output is t pi n. Okay, okay. Are you all able to get this? Great, great. Okay, so this is the whole concept of sampler, that is we simply replace t by nts in this whole case. Okay, so now let's move on to this question. So similarly in this question also we can do it. It is very easy to solve. That is, input is cos of 200 pi t, and here ts is equal to 1 upon 100. So we can get the output. How we can get the output? So this is a sampler, right? So output is simply putting t equal to nts in the input. We simply put t equals to nts. Okay, we simply put n equals to t equals to nts, and we can get the result, that is output is equals to cos of, so we can get the output is cos of 2 pi n, and remember that n can only be integer. Now here we have to find out the output at t equal to 5. We have to find out the output at n equal to 5, sorry. At n equal to 5, the output is equal to cos of 10 pi. And what is cos of 10 pi? Cos of 10 pi is equal to 1. Cos of 10 pi is equal to 1. I hope all of you are able to do it. Yes. So let's move on, bachcho. Let's move on. Great. So after completing sampler, now we will be moving to the elementary analog signals. Elementary analog signals, two are most important, that is unit step and delta. Unit step and delta are most important. Okay. So unit step and delta are most important. How can we solve it? How can we understand it? So let's do it. So unit step function is defined as ut. Okay. So what is t? T is a dependent variable. T is a dependent variable. It is 1 for t greater than 0 and 0 for t less than 0. Okay. And thus when we draw it, we will get a figure like this, that it is 0 for t less than 0 and 1 for t greater than 1. We can also see that there is a discontinuity at origin. At t equal to 0, we have a discontinuity. Okay. Now this person is Gibbs. Okay. Now this person says that whenever in a signal there is a discontinuity, then the value of the signal at that point is equal to, remember this, Gibbs says that whenever we have a discontinuity, then at the discontinuity point the signal will have a value that is equal to 1 upon 2 or half or average of the preceding value and the next value. Okay. At the discontinuity point the signal will have a value that is equal to the average of the preceding value and the next value at the discontinuity. So here we can see that at t equals to 0, if we follow Gibbs statement, then we can see that the value of the signal will be equal to that is 1 plus 0 divided by 2, that is 0.5. Okay, that is 0.5. Is it correct? Is it correct? Okay. Now let's move on. Now let's move on. Okay, so now let's move on. Let's move on. This is the basic definition of UT. This is the basic definition of UT. We have one more definition, that is basic, that is general definition. Now general definition is A times of U of AT plus B. A times of U of AT plus B, where capital A, small b are constants. Okay. Now using this definition only, we will simply modify it and we'll get the general definition. And what will be the general definition? The general definition will be, it will be A when AT plus B is greater than 0. Okay, now from here, where this definition is coming, we can see that when the variable inside, when the term inside the bracket is t, then ut is equal to 1 when t is greater than 0 and 0 when t is less than 0. Here we can see that inside the bracket we are having a term that is AT plus B, and thus we will have the signal value is equal to A. Why A? Because it is getting multiplied by A. And why, when will be it is equal to capital A? It will be equal to capital A when the term inside the bracket is greater than 0. When the term inside the bracket is greater than 0, and 0 when the term inside the bracket is less than 0. Is it correct? So it is equal to capital A when, from here we can see that when t is less than minus b by a. Okay, so this is what we are getting. This is what we are getting. Okay, now let's solve one or two examples for more clarity. Okay, so what is u of t minus 1? U of t minus 1, the value will be equal to 1 when t minus 3 is greater than 0. Okay, u of t minus 3, it is equal to 1 when the term inside the bracket is positive. Okay, and 0 when the term inside the bracket is negative. So it is equal to 1 when t is greater than 3 and 0 when t is less than 3. So we can draw it like this. We can draw it like this. Okay, it is like this. Okay, so value is 1 when t is greater than 3 and 0 when t is less than 3. Now similarly we can draw it here also. Another example, that is 2 of u minus 2t plus 7. Now here we can see that this whole u function is getting multiplied by 2. So the value of this function will be equal to 2 or 0. The value will be 2 or 0, and when it will be equal to 2? It will be equal to 2 when the term inside the bracket is positive. Now when will be this positive? This will be positive when t is greater than minus 7 by 2. Now since there is a minus sign both sides, and when we remove this minus sign, the inequality changes its sign. Okay, inequality is greater than right now, it will become less than. And it will be 0 when t is greater than 7 by 2. Okay, is it correct? Is it correct? Are you all able to understand this? So we can say that this signal will be 2 when t is less than 7 by 2, that is 3.5, and it will be equal to 0 when t is greater than 3.5. So it is 7 by 2 and height is 2.0. Okay, all of you are able to solve this. So always remember that 7 by 2. It is 0 when t is greater than 7 by 2. So always remember that how to solve this kind of problem. Similarly, here also we can solve it. The value is, since it is getting multiplied by -4, so the value will be -4 or 0. When the value will be -4, it will be equal to -4 when the term inside the bracket will be greater than 0. Okay, like this. Okay, now we can take 70 on the right side, so we can get that t is less than 4. Okay, now it will be 0 for t greater than 4. So we can draw it like this. Very easily we can draw it. For t less than 4, the height is -4. Okay, for t less than 4, height is -4. For t greater than 4, height is 0, or the value is 0. I hope all of you are able to understand this. Great. Now let's move on to the unit impulse function after doing the step function. So always remember that step function, the term which is inside the bracket is very important, and using that we can draw the unit step function very easily. Okay. Now let's move on to the impulse function. Okay. So impulse function is defined like this. The basic definition is it is written like this: delta t. So how it is defined? It is defined like this. The value is infinity at t equal to 0. Okay, the value is infinity. It is similar to an arrow which is tending towards infinity. So value is infinity at t equal to 0, and it is 0 elsewhere. It is 0 elsewhere. It is 0 elsewhere. At all other location it is 0. We can also see that thus definition is not complete. Okay, this is only a part of the definition. Okay, the value is infinity, the location is t equal to 0, and area is equal to 1. Now what is the area? Area is minus infinity to infinity, integration is equal to 1. That is, area is equal to 1. So we have a delta. What is the location of delta? We can see that the location is t equal to 0, value is infinity, and area is 1. Okay, so value is infinity, area is 1, and location is t equal to 0. So for a delta we need to know 3 things. Value is always infinity, so it is not important. Area, for this case it is 1. Location, for this case, is 0. Okay. Now before moving to general definition, so what will be the general definition? There are 2 parts. For example, for definition we need to know the area also, we need to know the location also. So here we are talking about location. For area we will be using the next 2 slides. Okay, so del AT plus B, so if anywhere we have del AT plus B, then what will be the location? Okay, the value is always infinity. What will be the location? Location means where the delta will be present at what t location the delta will be present. So remember that, simply put, this term inside the bracket equal to 0. Simply put, the term inside the bracket equal to 0 and you will get the location of the delta. Okay. Simply put, the term inside the bracket equal to 0, you will get the location, and 0 elsewhere. So what is the location of this? So we can say that the location is minus b by a. The location is minus b by a. Okay. And it is 0 elsewhere. So we got the location. Now we'll talk about the area. So if we talk about this, del t minus 3, del t minus 3. So what will be the location? So it will be infinity, where the term inside the bracket is 0. Term inside the bracket is 0 means at t equal to 3. So this delta is present at t equal to 3 and it is 0 elsewhere. Now if we talk about the area of this delta, area means minus infinity to infinity delta t minus 3 dt. Now how to find out this area? How to find out this integration? Simply put t minus 3 equal to alpha. T minus 3 equal to alpha. So it is minus infinity to infinity delta alpha d alpha. Now as we know that this integration is equal to 1. So the area is equal to 1. Area of this delta is equal to 1. Okay. Now, so we can see that this is simply a delta which has area equal to 1. The only thing is location is 3. So location is 3. Area is equal to 1. And what is the value? Value is infinity always. Okay. Now we'll talk about this, but first of all, let's talk about this first. Del 2t. So we can see that the value will be infinity, and where 2t is equals to 0. The term inside the bracket is 0. The term inside the bracket is 0. Now term inside the bracket is 2t. 2t equals to 0 means t equal to 0. Means location is t equal to 0 only. The location is t equal to 0 and 0 where? Okay, 0 elsewhere. Okay, now what we have to find out the area now. We have the location, we have the value is always infinity, we have the location, that is t equals to 0. Now we have to talk about the area. How to find the area? Area means minus infinity to infinity integration. Now we will put 2t is equals to alpha. So we can see that dt is equals to d alpha by, we'll put it. So this integration will become minus infinity to infinity delta alpha d alpha by 2. Now we know that this integration minus infinity to infinity delta alpha d alpha is 1. So we can see that the area is 1 by 2. So we can see that location is 0, value infinity, area 1 by 2. So area is 1 by 2. Okay, location is 0 and area is 1 by 2. So now from here we can conclude that the general definition. Now this definition is very, very important. Okay, this definition is very, very important for all of you. How it is important? Okay, so let's see. A times delta AT plus B. A times delta AT plus B. Can we find out the location of this? Yes, obviously we can. Obviously we can find the area, location. So what is the location? What is the location of this? Location is, value is infinity, and what is the location? Location is where the term inside the bracket is 0. But the term inside the bracket is 0. That is AT plus B is equal to 0. That is minus B by A is the location and 0 elsewhere. Now, what is the area? We have to find out the area also. So, what is the area? We can see that the area is affected by this term, the term which is with t, the variable t, the term which is with the variable t, that affects the area. So, the area of this will be 1 upon mod A multiplied by capital A, the term which is multiplied at the outside. Okay, the term which is multiplied outside also affects the area. So, two terms affect the area, and we can easily find out the location and area now. This is the general definition that we will use, that we will always use. Okay, that we will always use. Okay, now let's see one or two examples for more clarity, so that you can understand this very easily. Okay, so for example, we have 3 delta 2t plus 6. So, what is the area and location? We can see that the area and location will be, the location we can easily find out by putting the term inside the bracket equal to 0, that is t equal to minus 3, and 0 elsewhere. What is the area of this? Area is affected by this term outside and the term which is inside this with t. So, it is 3 by 2. Area is 3 by 2. Now, if we look at another delta, that is 3 by 2 delta t plus 3, what will be the area and location? We can see that the area will be, we can see that the location will be, the value is infinity and location is t plus 3 equals to 0, that is t equal to minus 3. Okay, and 0 elsewhere. Now, since with this t there is no term, there is only one, the only term which is outside is 3 by 2. So, what will be the area? The area will be 3 by 2. Okay, always remember that they are equal. Can you see that? They are equal. They have same location, they have same area, they have same location, they have same area. Okay, so these two delta functions are equal. These two delta functions are equal. Okay, now let me tell you one more example. So we can say that A times of del AT plus B is equal to A upon mod A del T plus B by A. Remember this. This is very important. Okay, this is very important. Okay, so now we have everything for the delta function. We can like do two or three examples for more clarity. Okay, for example, we have 3 delta minus 4t plus 6. So we can write it like this: A term will go outside with modulus, that is 3 by 4 del, and this A will get divided by B, this B will get divided by A. Okay, so this will become 4 minus 6 by t minus 6 by 4. Okay, now we can see that this is 3 by 4 delta t minus 3 by 2. So what is the area and location? We can see that the value is infinity at t equal to 3 by 2 and 0 elsewhere. So we can see that the location is 3 by 2, and what is the area? Area is defined by the term outside, because delta is having area equal to 1. So the area will be 3 by. I hope everyone is able to do it. Great. Let's move on. Let's move on. Okay. Similarly, last example, 4 delta minus 2t plus 6. This will become, this 2 will go out. This 2 will go out with modulus. So this will be 4 upon mod 2 delta t minus 3. So what is the area and location? The area is 2 and location is t equal to 3. Okay, now area is 2 and location is t equal to 3. Is it correct? Everyone is able to do it? Great. Let's move on now. Let's move on now. So what is this? What is this? When we are multiplying any signal with delta? We are multiplying any signal with delta. Multiply the signal with delta. Now, whenever we multiply any signal with delta, always remember that convert delta into the simplified format. Okay? Always remember to convert the delta into simplified format. So, how can we do that? This is xt multiplied by 1 upon mod a delta t plus b by a. Now we can also see that this delta has location minus b by a. Okay, delta is located, location of delta is minus b by a. Okay, location of delta is minus b by a. Now since delta is present only at this particular location, that is minus b by a, delta is located at the location minus b by a, when it will get multiplied by a signal, when it will get multiplied by a signal xt, then when it will get multiplied by a signal xt, then it will take out the value of the signal at that particular time instant only. Okay, whenever we can see that the delta function is located at a particular location only. For example, if we say that xt multiplied by delta t minus 5. Now since delta is present only at t equal to 5 location, so when it will get multiplied by a signal, then it will take out the value of the signal at that particular time instant only. Okay, because delta function is 0 elsewhere, it is non-zero only at t equal to 5 in this case. So it will take out the value of the function at t equal to 5. So let us take an example. So let us take a general case first. The location of delta function is minus b by a. So when this will get multiplied by this signal, we will get the value of the signal at minus b by a t plus b by a. Okay, always remember this is a very important result. Okay, let me do one example for you. Example. Okay, so let us do one example. So let us say we have to multiply xt with delta 2t plus 6. Okay, so first of all convert this delta into the normal form, into a simplified form. This will be xt 1 upon 2 delta t plus 3. So this delta is located at minus 3. This delta is located at minus 3. So it will take out the signal at minus 3. Okay, this will be the result. This will be the result. Okay. Similarly, one more example. For example, this. Similarly, here also we can do it. So this will be xt 1 upon 3 delta t plus 3. Okay. Now, here we can solve it. We'll get x of minus 3 delta t plus 3 divided by 3. Okay, so this is how we can solve it. Okay, x of minus 3 will be a constant value, x of minus 3 by 2 will be a constant value. Okay, now let's move on to the another type of problem that is to be answered. Okay, these are the type of problems that are asked in GATE exam and they are very popular. Okay, before doing this, let me take one more example so that you are able to solve it for more clarity. Okay, for more clarity. For example, we are integrating from 0 to 9. Okay, we are integrating from 0 to 9 3t square delta t minus 6. Okay, this is a signal that we have to integrate. This is the integration that we have to perform and we have to find the answer. Okay, now how to do it? First of all, this is getting multiplied by this, and how to solve it we know. Okay, so the location of delta function is 6. We'll put simply t equal to 6 in this equation. So we'll get 3 into 6 square into delta t minus 6 dt. Now we are integrating. What is the location of delta function? Location of delta function is 6. We are integrating from 0 to 9. Since the location of delta function is 6, thus when we integrate from 0 to 9, we will get this delta will give us 1, but this value which is outside, it will give us 3 into 36 integrating 0 to 9 delta t minus 6 dt. Now this integration will give us 1 because we know that the area of delta function, this one, is 1. Okay, so what we'll get? We'll get 108 as the answer. We'll get 108 as the answer. Is it correct? So now how to solve these kind of problems? I hope the concept is clear and it will get much more clear when we'll write the steps to solve this kind of problem. We'll write the steps to solve this kind of problem. So how to solve this kind of problem? Step number 1. First of all, we'll solve the delta function. One upon mod a delta t plus b by a dt. Now we know that the delta function is located at minus b by a. The location is minus b by a. Okay. Now suppose that the location of delta function is outside this integration limits. If the integration limits are not containing the delta function, suppose that the integration limit is not containing the delta function, then the result has to be 0, right? The result has to be 0. For example, in this case, the location of delta function is 6 and we are integrating from 0 to 9. So 6 is inside the integration limit. But suppose if the integration limit does not contain the location of delta function, that is, delta is outside the integration limit, then the result will be 0. Then the result will be 0. So location of delta function is minus b by a. So check if the delta function is not within the integration limit. Is not within the integration limit, then the answer is 0. Then the answer is 0. Otherwise solve करेंगे इसको, we can solve it. Step 2. How can we solve it? When this will get multiplied by this, then x of minus b by a, we know how to write it, right? We know how to write this. So x of minus b by a divided by mod a minus infinity to infinity. Now when we integrate this, say minus infinity to infinity, nahi? The C to D. Now since the delta function is within the integration limit, the delta function integration will give us 1 and this will be a constant term, that will be the answer. So x of minus b by a divided by mod a is the answer. Okay, how many of you are able to understand this? Okay, so how to solve this? So if we write out the summary here, the summary is the result is 0 if delta is outside the integration limit. Delta is outside the integration limit, and the answer is minus b by a divided by mod a if the delta is within the limit. Okay, the delta is within the limit. Okay, is it correct? Okay, so this is the summary and this is the steps. So step number 1 is find out the location of delta function. If the delta function is within the limit, then the answer is x of minus b by a divided by mod a. Otherwise, the answer is 0. So let's solve some questions. So what is this? This is equal to x of minus 15 by 4 divided by 4 delta t plus 15 by 4. Okay, t plus 15 by 4, this is the result. Okay, so very easily we can get this. Next is minus infinity to infinity delta t dt. We know that it is area of delta function, that is 1. Next, minus infinity to infinity 4 times of this. First of all, we will modify it, 4 upon 2 delta t plus 3 by 2 dt. Now we can see that this delta function is within the limit, so the integration result will be equal to 2. Okay, integration result will be equal to 2. Here we can see that the delta function is located. What is the location of delta function? Location of delta function is equal to 0. And we are integrating from 2 to 4. We are integrating from 2 to 4. So is the integration limit contains a delta function? No. The delta is outside the limit. The delta is outside the limit. The delta is outside the limit. So the answer is 0. Okay. So the answer is 0. I hope all of you are able to do it. Okay. So now let's move on. Okay. So this question. First of all, we can see that 3t plus 2t square divided by 2 delta t minus 5 dt integration minus 5 to 10. Now we can see that this delta is located at t equal to 5. Is it inside the integration limit? Yes or no? Delta is at t equal to 5. Yes. It is inside the limit. Yes, it is inside the limit. We can see the integration is from minus 5 to 10. It is inside the limit, and thus the result will be, simply put 5 in this term. 3 into 5 plus 2, 5 square divided by 2. Okay. So 3, 5, 15, 15 plus 50 divided by 2. Okay. Great. So this is 65 by 2, that is 37.5. No, sorry, 32.5. 32.5. I hope all of you are able to do it. Yes. Okay. Great. Everyone is able to do it? Great. Now let's move on this question. Okay, so there are two delta functions. Just try it, बच्चों. Just try it. You will be able to do it. Try it and try to mark the answer. Okay, so now let's solve this, bachcha logo. It is very simple question. We can see that the location of delta function is, what is the location of delta function? Location is -3. And what is the location? The location is -5. So both are inside the integration limits. Now we have to simply integrate it. We simply have to put the values. We have to put the value here. That is -5. So it is -5 into 5 plus 6. What is the value of here? That is 9 into -3 square. Okay. So it is -25 plus 6 plus 81. Okay. So we can see that it is 81 minus 19, that is 62. I hope all of you are able to do it. Okay. We check first of all the location of deltas, and we can see that since both are inside the integration limits, so simply we put the value t equal to -3, t equal to -5 here. Okay. Now, what is this integration? Now this is very, very interesting to solve. That this is del alpha d alpha. Del alpha d alpha means the delta is located at alpha equal to 0. The delta is at alpha equal to 0. Okay. Now, yt is equal to -infinity to t del alpha d alpha. Now, if the location of delta, we know that location of delta is alpha equal to 0. If t is less than 0, the integration is from -infinity to t. If t is less than 0, then integration limit that is -infinity to t, the integration limit that is -infinity to t will not contain the delta, will not contain delta, and thus it will not contain delta means the answer will be 0. So it means we can see it pictorially also. The delta function is located at alpha equal to 0. This is alpha axis. The delta is located at alpha equal to 0. Now, if you are integrating from -infinity to such value, we are integrating from -infinity to such value that the delta is not containing in the integration, then the answer is 0. And if t is greater than 0, if this upper limit is greater than 0, then obviously we can see that the delta will be inside the integration limit and the result will be 1, because whenever the delta is inside the integration limit, the delta will give us 1 integration. Then the delta will be within the limits, and thus the result will be, the integration result will be 1. Okay, the result will be 1. So we can see that yt is equal to 0 for t less than 0. When t is less than 0, then integration limit does not contain the delta, the result is 0. And if t is greater than 1, then the integration limit contains the delta function and the result is equal to 1. Great, clear? Is this clear to all of you? And we can see that, t greater than 0. And thus we can see that this yt is exactly similar to ut. Okay, yt is exactly similar to ut. Okay, so this is the result that we can see. We'll come to this, just one more example for more clarity. Okay. Okay, one more example for more clarity. Okay, so let us say that yt is equals to minus infinity say t delta alpha minus 3 d alpha. Now here we can see that the location of alpha is location of delta is alpha equal to 3. Delta is at alpha equal to 3. Okay, delta is at alpha equal to 3. Now integration is from minus infinity to 2 to t. Minus infinity to t is the integration and delta is at alpha equal to 3. Now obviously we can see that when t is less than 3, if the upper limit is smaller than 3, then this integration will not contain the delta and the result will be 0. Will not contain delta and the result will be 0. But if t is greater than 3, then if t is greater than 3, then delta is inside the integration and the result will be 1. And the result will be, okay. So here we can see that the result is equal to 1 when t is greater than 3 and 0 when t is less than 3. So this is equal to u of t minus 3. Okay, so remember this result. This is very important, and many a times the question have asked on this format of the problems, okay, where we have to integrate the deltas and we have to get the result. I hope this is clear to all of you. Great. Now let's move on. Now let's move on to the rectangular functions. What is the rectangular functions? This is also very famous functions in continuous domain. Very famous functions in continuous domain. Let's do it. Okay. So the basic definition is rect t by tau, and this is capital A. So this rectangle is defined as where tau is a constant, A is a constant. Okay, tau is a constant, A is a constant. So this rectangle is defined as a rectangle which has height capital A from minus tau by 2 to tau by 2. Okay, on what is the axis? The axis is t axis, obviously. This is time axis, t axis. Okay, so always remember that A rect t by tau is a rectangle of height capital A from minus tau by 2 to tau by 2. Okay, now we can see the example written here, that is 10 rect t by 20. So we can see that the height is the height is 10 and tau is 20. So since tau is 20, the rectangle will be from 20 by 2 to 20 by 2, that is minus 20 by 2 to 20 by 2. Okay, so we can easily draw this. We can easily draw this. Okay, So here we can see that the rect function will be from minus 10, rectangle function will be from minus 10 to 10 because the tau is 20, okay, and the height will be 10. Height will be 10, okay. So this is the rectangle that we will get, okay. Now let's move on. Okay, now let's move on to the general definition. Sometimes it is very difficult for scaling and shifting of the rectangular function, thus we go for the general definition. For example, we have a rect and inside the bracket there is some numerator and some denominator. Some numerator and some denominator. So how to solve it? The a rect t by tau, it is a rectangle. It is a rectangle which has a range from t from minus tau by 2 to tau by 2. Okay, so we can see that here numerator is t and denominator is tau. So this is the range. This is the range, and similarly, using the same concept, we can write it like this. It is a where the numerator is less than denominator by 2 and minus denominator by 2 and 0 elsewhere. Okay, so this is a very important relationship, and then from where we are getting this? We are getting from here only. This is the numerator, this is denominator by 2 minus denominator by 2. Okay, so let's see one example. Suppose this is the example. Let's see, let's take a simpler one, minus t. Okay, okay, so how to solve it? Just put it here. So what is a? What is a? The height is 5. And what is the range? Minus denominator by 2. What is denominator? 50. Okay, so minus 25 minus t plus 2, 25. And from here we can see that easily subtract 2 first of all. First of all, subtract 2, that is minus 27, that is minus 27 to 23. And since there is a minus sign, we will interchange the inequalities and put a minus sign. Okay, and 0 elsewhere, 0 elsewhere. Great. All of you are able to do it? Now, so we can easily draw this also. We can easily draw this. That's it. It is from minus 27 to 23 to 27. Height is 5. So like this, you can draw any rectangle. In any case, it comes in any exam. Okay. One more example for more clarity. Suppose we have to write 5 minus 2t plus 5 divided by 50. Okay, so let's do it. So this will be equal to 5, and what is it? What will be the range? Numerator and denominator. Denominator is 50, so denominator by 2 will be 25. So this will be okay. Now we solve it. First of all, let's subtract 5. So we'll get minus 2t, 20, 30. Okay, now we'll interchange this, minus 10 to 15, okay, and 0 elsewhere. So there is no need to do scaling or shifting. We can directly use this equation and get the answer. So we'll get a rectangle from minus 10 to 15. What is the height? The height is 5.5. I hope there is no issues in this. I hope there is no issues in this. Let's move on. Let's move ahead. All of you are able to solve this? Great. Now, similarly, we have a triangular function also. We have a triangular function also. The triangular function is, the basic definition. Let us first of all write it and let's define it. Okay. So, it is a triangle T by tau. A triangle T by tau. What is this equal to? What is this equal to? A triangle T by tau. Here A is a constant, tau is a constant, and triangle is a symbol of the triangle. And this is a triangle which is from minus tau to tau. Always remember the range. Okay, always remember the range. And the maximum value is given by capital A and it is at the center. It is at the center. Okay, center of the limits. Center of the limits. Okay, now let's see an example. Example, let us say 15 triangle T by 20. So we'll get a triangle. We'll get a triangle from minus 20 to 20. We'll get a triangle from minus 20 to 20. Okay. And what will be the location of maxima? The location of maxima will be the center point. Now, what is center point? So, minus 20 and 20, what will be the center? The center will be origin only. And what will be the maximum value? Maximum value is 15. Okay. So, we can see that the range of this rectangle is minus tau se lekar tau tak. Okay. The range of the triangle is minus tau to tau. I hope all of you are able to do it. Great. Now let's see the general definition. Okay, let's see the general definition. The similar manner in which we have done the rectangle ones. There is some numerator and some denominator. There is some numerator and some denominator. So this is a triangle. Within the range is given to us. What is the range? The range is, now just tell me, I want all the students to answer. Just tell me what is the result. The result is numerator less than denominator greater than minus denominator. Okay. So numerator less than denominator greater than minus denominator. And this is what the equation is. So this is the range of the triangle. The maximum value of the triangle at the center point. Now, how to write the center point? The center point is equal to the average of the ends. Okay, average of the end points. Average of the end points. Okay. Great. So let's do it. Let's do it. Let's take one example here. For example, we have 5 triangle minus 2t plus 10 divided by 50. Okay. So only one example is more than sufficient for clarification and for illustrating the the method. So it will be a triangle, and what will be the range? The range will be minus 2t plus 10, that is numerator less than denominator greater than minus denominator. Okay, this is the range, and we'll subtract 10 from, oh sorry, denominator by 2 nahi karna hai. Here we have only denominators. So it is 50 and minus 50. Subtract 10 from both the sides, we'll get 40 and 60 minus Now we'll divide by 2 and we have a minus sign also, minus t. So we'll get minus 20 to 30. So we'll get a triangle from minus 20 to 30. What will be the maximum value? The maximum value will be minus 20 to 30. The maximum value will be 5.0. And what will be the location? I told you the location of maxima is the average of the ends. So average of the ends is 30 and minus 20. What is the average? Average is 30. 30. What is the average? How to find the average? So average is 30 plus minus 20 divided by 2. That is 5. Okay. So 5 is the center point or the average point. So this is the triangle that we will get. Okay. So how to find the range? We know that where the maximum value, we know the end points, and then we can get the center point, and the maximum value is given by this. So this is how the triangle can be written. I hope all of you are able to do it. Great. Now the last elementary analog function is the ramp function. Okay. The ramp function, and the ramp function is represented by RT. The ramp function is represented by RT. Okay. The ramp function is represented by RT. It is written as TUT. It is written as TUT. Now how to write this? So we know that ut is equal to 1 for t greater than 0 and 0 for t less than 0. Okay, 0 for t less than 0. So TUT will be equal to simply multiply it by t. So it will be equal to t for t greater than 0 and 0 for t less than 0. So it is drawn like this. Okay, it is drawn like this. Initially it is 0. And then it is a line, straight line, which has slope 1. Okay, we can see that for t greater than 0, this is 0. For t greater than 0, we get ramp is equal to t, that is a function which has, or a straight line which has a slope of 1. Okay, this is a straight line which has a slope of 1. I hope all of you are able to do it. Okay, it is a straight line which has a slope of 1. I hope all of you are able to do it. Great. Let's move on. Now, okay, suppose I multiply it by 3. Suppose I multiply it by 3. So I want 3RT. So what is 3RT? 3RT will be 3TUT. Means we will get a function which has a slope of 3, right? We will get a function which has a slope of 3. So initially it will be 0. Okay, and then it will be a straight line of slope 3, right? It will be a straight line of slope 3. Slope 3.0. I hope all of you are able to do it. No issues here. Okay, it will be, the equation will be 3t. Okay, the slope of 3. Now let's move on. Okay, one more thing here for more understanding, for more clarity, that is, I have to add a page. Okay, suppose we want RT minus 1. What is the meaning of this? RT minus 1. So it means that it is simply equal to, first of all, let me make it very clear that RT is equal to TUT. Okay, RT is equal to TUT. Now, if I put T minus 1 here, then obviously it will be T minus 1, UT minus 1, okay? T minus 1, UT minus 1, okay? Now, here we can see that UT minus 1 means, UT minus 1 means, UT minus 1 means it is equal to 1 for T greater than 1 and 0 for T less than 0, okay? Thus, we can say that what is RT minus 1? RT minus 1 will be equal to T minus 1 for T greater than 1. Sorry, it is 0 for T less than 1. 0 for T less than 1. So, it will be a ramp which will be starting from 1. Okay. So, what is RT minus 1? RT minus 1 is a ramp which is starting from T equal to 1. It will be starting from T equal to 1. Okay, it will be a ramp. And what will be the slope, bachcha logo? What will be the slope? We can see that the equation is T minus 1 and thus the slope is 1. Okay, so here we have slope is equal to 1. So it is a ramp which has slope equal to 1 and it is starting from T equal to 1. So just one more thing that will be required here actually. Thus, if we need a ramp from T equal to 1, if we need a ramp from T equal to 1 that will start from T equal to 1, then the equation is RT minus 1. Similarly, if we need a ramp which start from T equal to A, let us say T is equals to A is any random time. So the equation will be RT minus A, RT minus A. Now, all these ramps, this one, they have slope equal to 1. They have slope equal to 1. All these ramps have slope equal to 1. Now, if you need a slope of some other value, for example 2, for example 3, for example 4, then we will use the last statement. If we want a ramp that to start from T equal to A and has a slope of capital A, then it will be written as capital A RT minus A. Okay, we'll just simply multiply with that capital A with the ramp. Okay, we'll simply multiply the capital A with the ramp. So this whole concept will be used here. Now the topic is representation of a signal. So any signal is given and we have to represent it in terms of ramp and unit step. We have to represent a signal in terms of ramp and unit step. Okay, ramp and unit step. Okay, now whenever we are representing any signal, we need to see only two things. What are the two things? The first is jump jump. Just remember or recall the unit step function. The unit step function has a jump, okay, has a jump. So jump is given by the step function, or the jump is supported by the step function, and we need to see the slope change. Slope change is supported by the ramp. Slope change is supported by the ramp. So we need to see only two things, that is jump and the slope change. So let us see. We all know what is the slope, okay? We all know what is the slope. Suppose we have a straight line and it has 2 points, that is x2, y2, and another point is x1, y1. Okay, then the slope will be y2 minus y1 upon x2 minus x1. So this is the slope, and wherever there is a slope change, whenever there is a slope change, then we have a ramp at that particular location. Okay, and whenever we have a jump, we have a step function. Okay, now how to see a jump? Let us see an example. What is the meaning of jump? What is the meaning of slope change? What is the location of slope change, and what is the location of jump? So how to find out all of this? We have examples for it. Okay, let's see. So let us try to solve an example where we can easily see all the points of jump and slope change. Okay, so this is an example. So how to see the jump? I have a method for it. Let me illustrate it. Suppose this is a curve. This yellow line is showing the curve, and on this yellow line, suppose that you are riding your bike. So you are riding your bike, we can easily go up, but at this location you will fall down. Okay, so whenever we fell down or we rise up, there we have a jump. So we can see that we have a jump at t equal to 1. So this is the location of jump. Okay, and what is the amount of jump? The amount of jump, we are going downwards, and thus the amount of jump is this height, the height by which we fall. Okay, so we can see that we fall by, the value of jump is -1. So we have the location, we have the jump value. Okay, so wherever we have a jump, we will have a step function, the unit step function. Okay, so we have a jump at t equal to 1, so it will be represented by ut minus 1. And since the amount of jump, the value of jump is -1, we will multiply it by -1. Okay, next point. We can see that the initial slope is 0. We can see that the initial slope is 0, but after that, here we have a rising curve. Which has slope equal to 1. Okay, so here we have slope equal to 1. So we can see that at t equal to 0, the slope changes from 0 to 1. At t equals to 0, the slope changes from 0 to 1. We can see that the slope changes from 0 to 1 at t equal to 0. Similarly, at t equal to 1, the slope changes from 1 to 0. Okay, because here we can see that the slope is again 0, but here we have slope equal to 1. So at t equal to 1, the slope is changing from 1 to 0. So always remember that we have to find out the amount of change. So it is going from 0 to 1. What is the amount of change? The amount of change is plus 1. The slope is going from 1 to 0. The slope is going from 1 to 0. The amount of change is minus 1. The amount of change is minus 1. So we can see that we have change of slope at t equal to 0 and change amount kitna hai? What is the amount? Amount is plus 1. We have slope change at t equal to 1 and what is the amount of change? Amount of change is minus 1. Okay. So we need a ramp of slope 1. We need a ramp of slope 1 at t equal to 0. That is represented by RT. That is represented by RT. Now we have a ramp. We need a slope change of minus 1 at t equal to 1. So we need a ramp of slope minus 1 at t equal to 1. That is minus 1 multiplied by RT minus 1. So finally we'll club all this and we'll get the signal. So what is the signal? We need a jump of minus 1 at t equal to 1. So jump of minus 1 at t equal to 1. We need a ramp at t equal to 0 of slope 1. We need a ramp of minus 1 slope at t equal to 1. So this is the representation of the signal. Okay, is this clear to all of you? Now, one more example for more clarity. Okay. So, not example, just writing a point. So, if we have a jump of A at t equal to A, then it will be represented by a step function where that is A times of ut minus A. Okay. Similarly, if we have a slope change, if we have a slope change of A at t equal to A, it will be represented by ART minus A. Okay, ART minus A. Is it correct? Great. So one more example for more clarity. Here we can see that this is the curve, this pink one. So where will we will have an accident or where we need to jump. So we have a bike, we are moving, no issues. But here we need a jump of plus 4. We are moving from minus 4 to 0. So we are moving above, we are moving upwards, we are moving upwards. So here we have a jump of plus 4. So we have a jump of plus 4 at t equal to 0. We have the location and we have the amount of jump. Next, at this location, we have slope equals to 0. And in this line, in this duration, we have a slope of negative slope. We can see that there is a negative slope. The change in height is 4. The change in width is 2. So we can see that the slope is minus 2. The slope is minus 2 and again the slope is 0. Okay, the slope is 0. So we can see that we have a change of slope from 0 to 2 at t equal to minus 2. This is minus 2 point. Okay, the slope is changing from 0 to 2. Similarly, 0 to minus 2, sorry, 0 to minus 2, okay, the slope is negative. Now at t equal to 0, the slope is changing from minus 2 to 0, the slope is changing from minus 2 to 0, and thus what is the amount of change? The amount of change is minus 2, okay, the slope is going from 0 to minus 2, the amount of change is minus 2. So how to see, sir, how to see the amount of change? The amount of change is equal to the next value of slope minus previous value, okay. So minus 2 minus 0, that is minus 2, and what is the amount of change? The next value of slope minus the previous value, that is 0 minus minus 2, that is plus 2, okay. So we have a slope change of minus 2 at t equal to minus 2. We have a slope change of plus 2 at t equal to 0. Is it correct? Great. So now we just have to write the expression and we'll get the answer. So from here we will get 4 times of ut, okay. From the second point we need the slope of minus 2. So minus 2 from t equal to minus 2. So t equal to minus 2 means t of minus 2 and slope of 2 from t equal to 2. So we can see that this will be 4 times of ut minus 2 times of RT plus 2. Okay, so this is the result. Okay, so from here or this analysis we can easily solve any kind of problem. Okay, so this is also we can solve very easily. The slope is 0. Here also the slope is 0. Okay, and here also the slope is 0. The slope is not changing anywhere. The only places we can see that at t equal to 2 we have a jump. At t equal to 4 we have a jump downwards. Okay, so this is upwards and this is downwards, upwards and downwards. So what is this? Height is 1. So what is upward? It is going upward. So it is jump of plus 1 at t equal to 2. And it is jump of minus 1 at t equal to 4. So we will solve this. So jump of 1 at t equal to 2, jump of minus 1 at t equal to 4. This is the result. I hope all of you are able to do it. Everyone is able to do it. Great. So let's represent this signal also. Okay. So first of all, we can see that there is a jump at this location. There is a jump at this location. Okay, jump of minus 10. Jump of minus 10 at this location, minus 5. Here also we can see that now this is very important to observe. Okay, please observe this. We are going here, then we are going downwards. Okay, then moving like this. At this location again we are moving down. So here also we have a jump and it is downwards. So at this location also we have a jump and it is downwards. Okay, so at both the locations, that is minus 5 and 5, we have jump which is downwards. Jump which is downwards. Okay, and what is the amount of jump? We can see that the amount of jump, it is going from 0 to minus 10. So it is downwards by 10. It is downwards by 10. Downward by 10. Okay, now initially the slope is 0. Initially the slope is 0. Now from this point to this point, we can see that the slope is positive. The slope is positive. Okay. It is going from minus 10 to 10. It is going from minus 10 to 10. Okay. It is going from minus 10 to 10. You get it? Okay. Minus 10 to 10. And what is the amount of width? The width is 10. So this is width is 10. This height changes 20. Height changes 20. Width is 10. And thus we can see that the slope is plus 2. The slope is plus 2. Okay. So we can see that the initial slope is 0. The slope is 2. And then the slope is 0 here also. So slope change we can see that the slope here is 2, initial slope is 0, so slope changes 2 at t equal to minus 5, okay. And then again, here the slope is 2, the slope is 0 here, so slope change, slope is going from 2 to 0, that is slope changes minus 2. At t equal to 5. So thus from here we can easily get the ramp and the unit step. So here the unit step is minus 10 u of t plus 5 minus 10 u of t minus 5, and then ramp is there. So 2 r t plus 5 minus 2. This is the whole representation. Okay, great. So I hope all of you are able to do it. Great. So now let's move on to the elementary discrete signals. The elementary discrete signals. Okay. So elementary discrete signals are very easy to understand with respect to the elementary analog signals. Okay. So let us see this. Okay. So as we know that in the discrete signals, the variable is n. The variable is small n, and thus variable is small n, and thus also we know that n can only be an integer. N can only be an integer only. Okay. Now we have one more method to represent. We can represent any signal xn as a function, for example like this 2n minus 1, or we can represent it like this 2n square, or any function of n. So signal can be represented as any function of n, but the only thing here is that n has to be integer. That's it, nothing else is required. Okay, now we have one more method to write the discrete signals. Okay, so for example, discrete signal can be written like this. So directly we write the values of the signal. We write values of the signal directly. Okay, so for example 3, 2, 1, 0, 3, 2, 4, and so on, anything. And there is an arrow in this representation. So this arrow is showing the location of n equal to 0. This arrow is showing the location of n equal to 0. So what is the meaning of this? It shows that at n equal to 0, what is the value of the signal? The value of the signal is 1. And what is this then? This is n equal to 1. So at n equal to 1, what is the value of the signal? 0. This is n equal to 2. What is the value of the signal at n equal to 2? 3. n equal to 3. What is the value of signal at n equal to 3? That is 2. 4. At n equal to 4, value of signal is 4. This is -1 location. The value of signal at -1 is 2. The value of signal is -2 is 3. Great. Understood everyone? So this is also the method of representing any signal. Now let's see the two very basic discrete signals, that is unit step and the delta functions. Okay. So unit step sequence, it's a very similar to that of the unit step signal that we have studied in the elementary analog signals. So for example, un, it is equal to 1 when n is greater than or equal to 0 and 0 when n is less than 0. Okay. So here we have the n axis, and in the n axis at 0, 1, 2, 3, at 0 we have the value 1.0, at 1 we have the value 1.0, at 2 we have the value 1.0, and so on. So we can see that for n greater than or equal to 0, the un is equal to 1. Great. Okay. Now we have, this is the basic definition. We have the general definition also. U of an plus b multiplied by capital A. Okay, where capital A, small b are the constants. These are the constants. Okay. Now the value of this function is capital A, where this term, the term inside the bracket is greater than or equal to 0. Okay, and 0 elsewhere. And one more thing, it is very important, that is n has to be integer only. N has to be integer only. Understood everyone? Sorry. Now let's see one more example. One example here, just for sake of clarity. For example, 5 times of u of 3n plus 4. Or let us say one more example, u of n plus 3.5, let us say. Okay. So we can see that this will be equal to 5 when n plus 3.5 is greater than or equal to 0 and 0 elsewhere. So from here we can see that it is n greater than or equal to minus 3.5. N greater than or equal to minus 3.5. Now it is very important to understand that n greater than minus 3.5 means, so this is n axis. So let us say this is 0, minus 1, minus 2, minus 3, and this is minus 4. So will this signal start from minus 3.5? Yes or no? The answer is no, because n has to be integer. So this means n is greater than or equal to minus 3.5. So with this condition, it is very important that n has to be integer. Now for n to be integer, n greater than or equal to minus 3.5 means this signal will not start from minus 3.5. Rather, it will start from minus 3. So this signal will have value 5 from n greater than or equal to minus 3, not 3.5, because 3.5 is not the integer. I hope all of you are able to understand. The condition says that the function is equal to 5 in this region, that is in the value n greater than minus 3.5. But since this is not integer, it will not start from this location, rather it will start from this location. Okay, understood everyone? I hope all of you are able to understand this point. The exactly similar question is there on the next slide. Okay, for example, we have 4u of minus 3n plus 4. Okay, so it will be 4 when minus 3n plus 4 is greater than equal to 0. Great. So from here we can get that n is less than equal to 4 by 3. Understood everyone? Now that is n is less than equal to 1.33 and 0 elsewhere. Now since 1.33 is not an integer and on the axis 1.33 is between 1 and 2. So this function is equal to 4 when it is less than 1.33. Less than 1.33 means less than 4 by 3. Less than 4 by 3. Now what is the integer less than 4 by 3? That is 1. So this function will start from 1, 0, minus 1, minus 2, minus 3 and so on. So this will not start from 1.33. Rather it will start from 1. Okay, I hope this point is clear because n has to be integer. This function exists in this region, but this will exist only where the n is integer. So this will exist only at 1, 2, 1, 0, minus 1, minus 2, minus 3 and so on. Great. So let's move on. I hope everything is clear till this point. Next is unit impulse sequence. Okay, unit impulse sequence means del n. This is very simple. In delta t we have very complexity because the value is infinity and area differs, area changes, area is different. But here the value is 1. Okay, the value is 1 directly. So the value is 1 where n is equals to 0 and 0 elsewhere. The value is 1 where n is equal to 0, otherwise it is 0. Okay, so the value is equal to 1 at n equal to 0, the value is equal to 1.0. So this is very simple, that the delta function has value equal to 1. That is very simple. Now if we talk about the general definition, the general definition will be, let me take an example. The general definition is delta an plus b is equal to 1. The value is equal to 1 irrespective of anything. The value is equal to 1 where the term inside the bracket is 0. Where the term inside the bracket is 0. Where an plus b is equal to 0 and 0 elsewhere. And 0 elsewhere. Okay. So this is the result. Okay. Let's see our examples. Let's see few examples. So delta 2n, the value is equal to 1 where the term inside the bracket is equal to 0 and 0 elsewhere. Okay. So we can see that this is equal to 1 where n is equal to 0 and 0. So we can see that, is this same as del n bachcho? Is this same as del n? Yes. So del 2n is equal to 1 where 2n is equal to 0 and 0 elsewhere. 2n is equal to 0 where n is equal to 0. So this is what we will get, and this is same as del n. Remember that del n or unit impulse sequence has value equal to 1 and nothing related to area. Okay, because this is discrete domain, so we don't have area term here. Okay. Now the second one, this is equal to 1, where n plus 2.5 is equals to 0 and 0 elsewhere. Now, this says that this function is equal to 1. This function is equal to 1 at n equal to 2.5 minus 2.5. Now, remember that in discrete, n cannot be a 2.5, n cannot be minus 2.5 because n can be only integer, Now, since n can be only integer, thus this condition will never arrive. And thus this signal is 0 always. Since n cannot be minus 2.5, so n cannot be minus 2.5, so del n plus 2.5 is equal to 0 always. Okay, n cannot, this has to be 0 always. So this is a 0 signal, it is 0 always, So similarly, here also we can see that this will be 1 when n is equal to minus 4.5 and 0 elsewhere. Now, since n cannot be minus 4.5, so this is 0 always. Okay, remember this, it is 0 signal, it is 0 always. Now this 4n plus 3, this is equal to 1 when n is equals to minus 3 by 4. Can you see this? This is equal to 1 when n is equal to minus 3 by 4. Now n cannot be minus 3 by 4 because n has to be integer only. So it is 0 always. Since n cannot be minus 3 by 4, so it is 0 always. Okay, it is 0 always. Now the last one, so it will be equal to 1. It will be equal to 1 when this term inside the bracket is 0, that is n equal to minus 4 and it is 0 elsewhere. So we have 1 at minus 4. So n is, this is integer value. So yes, it is a non-zero signal. It will be 1 at n equal to minus 4. This will be 1 at n equal to minus 4. I hope all of you are able to get this point. Next, the general definition. Let us see the general definition. We have already seen this. So, since it is getting multiplied by capital A, so it is equal to capital A at n is equal to minus b by a, is 0 elsewhere. Now, after looking at 2-3 examples, I hope all of you are familiar with this point that if this value is non-integer, then this is a 0 signal. If minus b by a is not integer, then this signal is 0 signal. This is a 0 signal. Okay, this is a 0 signal. Always remember that this will be a 0 signal. It will be 0 always. Okay, it will be a 0 signal. I hope all of you are able to get this. So remember this point, it is very important. Now, let's come on to the similar analysis as we have done in the continuous time domain. So, what is the analysis? This signal multiplied by the delta. Signal multiplied by delta. Okay, signal multiplied by delta. So when we multiply any signal with the delta, so it is almost in the same manner that we have done in the continuous time domain. So what is the process? The process is, there are two things. First is, we know that del an plus b, we have to find out the location. The location is minus b by a. Now if this location is not integer, then this del an plus b is a zero signal. Okay, if this is not integer, then this is a zero signal, and since it will be a zero signal, thus the result will be, the product will be 0. The product will be 0 because anything multiplied by 0 is 0 always, right? But if it is an integer, if minus b by a is an integer, then as we know that delta will multiply, the delta will get multiplied by the signal only at this particular location. So in that case, this will be x of minus b by a del an plus b. Okay, understood everyone? So I hope this is clear to all of you. Now before moving to this, let's do some examples. So one or two examples for more clarity. Example. So suppose we have to find out xn del 2n plus 3. So we can see that this location is not integer, right? The location is minus 3 by 2. So this is 0 signal. Okay, this is always 0. Example, xn del 3n plus 9. Now this is an integer location. We can see the location is minus 3. So this is this. Okay, now four n plus 9. So we can see that this is non-integer location. So answer is 0. Okay, the answer is 0. So this is how you can very easily do all of this. Now let's move on to the next point, that is the summation point. Okay, summation of xn del an plus b. Summation of xn del an plus b. So let's do this. First of all, how to solve this? C to d xn del an plus b. So how to solve this? We have 3 steps to solve this kind of problem. Step number 1. The step number 1 is find out the location of delta function. Okay, find out the location of delta function. Find out the location of delta function, and we can see that the location of our delta function is minus b by a. If this is a non-integer, if this is not integer, if not integer, then answer is 0, because this whole result will be 0 and summation of 0 is always a 0. So answer is 0. Otherwise, move to step 2. Step 2. If minus b by a is integer, then remember the step which we have done in the continuous domain. Then we will check the location of delta function. Is the location of delta function within the summation limit? So if this is an integer, then check that minus b by a is within the summation limit or not. Within the summation limit. If no, then again answer is 0. If yes, Then step 3. Then we'll move to step 3. So what is step 3? So step 3 is, we move to step 3. What is step 3? Step 3 is, we will write this summation as x of minus b by a del an plus b. Now this summation contains the delta, okay, that is already checked in step 2. Now the delta is value equal to 1 and this has some value. So we can see, we can take this out. So this is x of minus b by a d to d del an plus b. Now this delta function has value equal to 1, okay. So summation will be equal to 1. So this summation will be equal to 1 and the answer will be x of minus b by a, okay. So the result is, this is the result. So what is the result? The result is that if minus b by a is not integer, answer is 0. If minus b by a is not in the limit, then again answer is 0. Okay. If these two conditions are satisfied, if minus b by a is integer and within the limit, then answer will be x of minus b by a. This is what we have to do. These are the 3 points that we have to keep this in mind while solving any kind of such problem. Okay. So now let's draw this first of all. This is the delta function located at 0. So this will give me a delta at 0. This will give me a delta at 1. This will give me a delta at 2. 0, 1 and so what is the height? Height is always 1 because it is delta function. Okay. So 1.0, 1.0, 1.0. Great. What is this function equal to? This function. So we can see that yn is equal to summation m is equals to 0 to infinity del n minus m. So we can see that this summation is del n. We'll put m equal to 0 here, m equal to 0, m equal to 1, m equal to 2 and so on. So if we draw this, we will get a delta at 0 location, we will get a delta at 1 location, we'll get a delta at 2 location. Similarly, we will get a delta at 3, 4, 5, 6 and so on. So we can see that does it look like un, bachcha logo? Does it look like un? Yes, it looks like un. It looks like un. The value is 1 at 0, 1 at 1, 1 at 2, 1 at 3, 1 at 4, 1 at 5 and so on. So it looks like un. So this signal is equal to un. In such kind of problem, just open the summation and you will get the insight of the question very easily. Okay. Now let's solve this. Let's solve this. So let us say summation n equal to 4 to 7 Cn delta 4n plus 3. So we can see that the delta function here has a non-integer location. The location is n equal to minus 3 by 4, a non-integer location, and thus since it is a non-integer location, the answer is 0. The answer is 0. Okay? Okay. So thank you GW soldiers. In this whole part we have completed the type of signals, that is elementary signals. We have done the representation of signals. We have done the multiplication with the delta functions, integration and summation problems. In the next part we will be covering the operation on signals, that is shifting, scaling and inversion, and we will be doing the type of signals, that is energy, power signal, periodic signals. Okay, so these are very important and we will be continuing in the next part. Thank you. Bye bye.